folks, welcome to a great afternoon here of specialized segments. This is one of those Friday editions, and you know what that means? Yeah, we're not going to be answering phone calls today. That's one thing. Don't call in live, but feel free to send us some questions on our good old email account, Facebook, Twitter. But in case you were wondering, I'm Ernie Roberts, and I'm your host for TNLearn Mathline specialized segments. Now, what we do today, we're going to explore some topics a little more in depth without having to worry about calling ins and things like that. We try to give you a nice little tutorial session here. And if you'll sit back, relax, get those pencils, pens, maybe a calculator, and let's do some math, all right? And let's see what we're going to be doing today, speaking of that math that we've got coming our way. It says, breaking up is not hard to do. You know that song, breaking up is hard to do? Well, breaking up is not hard to do here on what we're going to talk about today on Mathline. In case you're wondering, we're going to functions. We're going to be dealing with functions. We're going to be looking at piecewise functions as the program moves on. But before we start out with that, we want to take you back just through the concept of f of x, g of x, and what's it all about, all right? Because sometimes I know people tune into Mathline and you're going, whoa, you're jumping right into the big concept here and you haven't gone back and reviewed. So we're going to do that today. We're going to take you back to the beginning of functions and go back through the notation. The f of x, what is it all about, all right? And what it is, it's another way, a fancy way of saying, hey, I've got this function of x that is called 2x minus 1. So I'm going to put in a value of x that's going to be given to me, and what I'm going to do is multiply it by 2 and then subtract 1. That's what the rule says. Multiply your value by 2, subtract 1 from it, and that will be your result. It's an input and an output type thing, all right? So let's take a look at this function. It says f of x is equal to 2x minus 1. There you go, all right? So the idea here is putting in f of negative 3. That means, folks, everywhere we see an x, we're going to replace it with the negative 3. Now, how does that work? Well, pretty easy, doesn't it? Like I said, it's not hard to do. It's not hard to do. So let's see how we're going to break this thing out. We're going to put a negative 3 right in there, and we're going to subtract 1 from our results. Now, you got a 2 times negative 3. That you can do. You don't even need to go to the calculator today, I don't believe. Negative 6, we got a minus 1, and my friends, that is going to give us minus 7 or negative 7 in that case, all right? So there's our first answer there. Now, let's take a look at the function using 1/2. This time, same function. I'll rewrite it for you. Hope you all are writing these down along the way. That's why I say grab pencil and some paper. And what we're going to do is let's see what the function, if we put a 1/2 in, what happens? What happens? So we're going to say 2 times 1/2, and then we're going to subtract 1. So basically what we're asking is, what's half of 2? What's half of 2? Well, that's 1, and that equals 1 minus 1, which will give us a grand total of 0. So there's your answer for the f, we call it f of negative 3, would be negative 7. And if we took the f of 1/2, here we go, would be 0. If you were to plot those two on the graph, you would find them to be points. You would plot them as negative 3, negative 7, coordinates, and then you would do this one as 1/2 and 0. Make a coordinate and plot it, okay? So that's what we're on to. That's what we're dealing with. These functions are just nice ways to name a relationship. It's almost like saying y equals something in terms of x. That's exactly what we're doing. Domain and range. You're going to hear those words popping up some today also. So let's take a look at our next functions, okay? We've got f of x, and we've got this time g of x. Now don't get all excited. It's just simply these are two different functions. A minute ago, we just had one function to work with, but here we've got two different functions that work differently when we replace the x value with a number, okay? So let's see, we've got f of x, start right over here with that, and it says x squared minus x plus 2. Now I'm going to tell you what I tell my students and everybody on Mathline. Watch your signs on this one, because we are going to figure out what is the f function of negative 2. So in other words, negative 2 is part of our domain that we're putting in for x, and we're going to see what output we come up with, all right, which would be part of our range if we were to do this for many, many numbers. So let's see, first of all, with our f function, we're going to put in a negative 2, we'll square it out, and then we're going to subtract a negative 2, and sometimes I like to put that parentheses around it, all right? Because this is a subtract, that's really a negative 2, but what happens is we're going to get the opposite effect here in just a second. We'll figure that out too. And how about it? By the way, always put that negative 2 up here where you're going to square in a parenthesis, because if you don't, that simply means we square it and then put a minus sign on it or a negative sign on it. That's not what we're wanting to do there. We still got this plus 2 that's hanging on for dear life, waiting for me to get there. Now we are there, all right? Now, let's see what we're going to get when we square and add and do all the good stuff that we need to do here. First of all, we're going to take negative 2 squared, and folks, it gives us a positive 4. Positive 4 there. This is going to be adding the opposite, which means basically add a positive. Add a positive. That's going to give us plus 2. And the plus 2, nothing changed because there's no x involved. It's just they're having fun, all right? Just like all of you all are on Mathline here. And remember, like I said, this is not going to be so hard to do because look what we're going to do. Add these together, 4, 2, and 2, we get 8. We get 8 there, all right? So like I said, what we're going through today is going to be relatively easy. Now, don't do anything with that 8 yet. Keep it on your paper. Keep it on your paper. We got to work some more. That's f of negative 2. Now we're supposed to use g of negative 6, which says, hey, Ernie, and the rest of you guys who are watching me today, go to the g function. Go to the g. Go to the g, all right? And let's see what that says. That says g of x equaling 1/2. And some of you get nervous about those fractions. Half of anything is easy to do. It's not hard at all. And let's see what happens when we put in a negative 6 into that mix, all right? So we're going to say take 1/2 of negative 6. That's what the idea is. Replace the x with the negative 6. And we're going to subtract 4, all right? And what's going to happen here, we got g of negative 6 equaling to, well, what is half of negative 6? This looks like negative 3. We're going to subtract 4. And you know what that's going to give us? Negative 7. Well, there's two numbers right there. I said, well, Ernie, what are we going to do now? According to our evaluate moment up here, we're going to take this result, which we found to be 8, and we're going to take this result, which we found to be negative 7. We're going to add them together. So let's do it. We're going to say 8 plus that negative 7, and you know what? That's just like subtracting 8 minus 7, and that's going to give us 1. So all that good stuff, when we put those numbers in, just simplifies down to a nice little answer of 1. Real quick noting on this. Big things, as I keep telling you to do, is watch your sign. When you put in that negative 2, put it in parentheses, just like it's attached to the f there, all right? That's a sweet little placeholder, all right? So you just put that little place right in there, and it worked out great to give us that 8. Over here, we had a negative 6, so put that little parenthesis in there for the x, and you work it right through there. Negative 3 minus 4, negative 7. Put the results together. Life, as they say, is good. It is good. All right. So that's the story. Let's keep those same two functions and let's do something maybe a little bit different, some numbers here. All right. Let's take it. This time we're going to subtract. Notice that big subtract right there in the center. All right. Now these are talking about negative 3s and negative 4s that we're going to replace our x's with. But anyway, let's see what's happening. First of all, the first indicator right here says f of negative 3 says use the f function, which in this case, our f of x is equal to, got it out there, ladies and gentlemen, x squared minus x, those x's are nice, and add 2. Here's what we just had on our last problem. This time, got a different value. We're going to work with negative 3, all right? So we're going to go ahead and figure out what is that f of negative 3. So we like to call it, what's the function of negative 3? It is going to be negative 3 squared minus a negative 3, and then we're going to tack on our lovely 2 because there's no effect on 2 with the x. So we're just going to tack it on to the final answer. Watch your signs again. This time should go a lot quicker. We got negative 3 times negative 3, which is going to be 9. Add the opposite, which is going to give us adding a positive 3. So it's going to be plus 3. And then you know what? We've got 2 equaling 14. 14 out there. 12 plus 2 gives us 14. Now, let's take the second side of this problem. We want to know what is g of negative 4. The g of x function, you got it. It's still at 1/2 x, and we're going to be subtracting 4. Now, I use that negative 4 here for a real good reason. You say, really? Yeah, really, I did. Let's see what I'm going to show you what it is. Here, we're going to put in half of negative 4. Be careful. We still have a minus 4 here, all right? That did not take care of that, all right? You've got to bring it back as you see it. So we're going to take half of negative 4, which is going to equal to, you all got it out there, right? Negative 2, and subtract that 4, you're going to have negative 6. Life is good. Life is good. Everybody with me on it? Now, you say, Ernie, are we done? Of course not, right? Because we got to subtract those two values. So here we go one more time. How about it? 14, which is our f of -3. And we're going to subtract our g of -4, which is a -6. And let's do the add the opposite routine. Here we go. 20 is your value when you put both of those together, all right? So again, it's just a nice little indicator. The f tells you go to the f function. The g says go to the g function. These are two functions that are basically working together. They're working together to give you a final expression, in this case, a final number, all right? And that's the story of today. That's the story of today. All right, now let's take a look at what we call the piecewise. I've been talking a little bit about that. At the beginning, it kind of gave you a little teaser. So we're going to look at piecewise functions. Notice here, we have just one f involved, one f of x. However, we're going to, instead of writing f of x equals and g of x equals, we're going to go ahead and let f of x be our main source here. That's one little difference here. But notice, obviously, saying x plus 4 is different than saying 2 times x minus 1. Those are entirely two different rules. And here's the deal. If, and that if is a big if I pick a value less than 2, that might be 1.9 or 1 9/10, it might be 1.0000009, those kind of things. Anything that is less than 2, or I could be 1.9999999, is still less than 2, I'm going to use this little guy right here, x plus 4. If it is greater than or equal, so here's the option for us using 2. Now notice, we've covered all possible values of x. If x is less than 2, we use this first equation. If x is greater than or equal to 2, we use our second one. And we're going to get a value of what those are equal to. So they're basic expressions, and we'll make an ace equals with the f of x equals x plus 4, or f of x equals 2x minus 1. So let's look at our values, because that's what it's all about. What's the domain? Our first domain says, remember, this domain is going to be a -2, all right? So that's running along the way, and I'm going to ask myself, less than 2 or greater than or equal to 2? Which one is it? Well, you all got that one, right? -2 is smaller than 2. So we're going to use our first one. So for f of -2, we are going to use -2 plus 4. So in other words, we're going to bring down our first function and use that and figure out what we get. Now, we have -2 plus 4. I believe it's going to give us a +2. Everybody good on that? That one was not hard, was it? Now, some of you said, well, what if we'd chosen the second one? Well, you get a number. It's going to give you something, but it doesn't make any sense because this x does not apply to this rule. You see, what's with the if, I'm looking for only x's that are greater than or equal to 2 to use this one. Our first one went with our x plus 4, all right? Now, let's take a look at our next one here, the f of 1. Notice, it is less than 2. So once again, we're back to this same rule here. So we're going to use our function of 1 is going to go with the x plus 4 amount. So we're going to use 1 plus 4. Oh, don't you love these easy numbers? You're going to get us 5. So what I'm talking about breaking it up is that sometimes you have to break up the whole domain to two different functions, and that's what we call them piecewise. Now, if you were to graph these, you say, well, Ernie, how do you know they're a function? Well, you never have a repeated value of x. In other words, with the -2, I can't come down here and do it here because it's not part of the domain for that function, all right? So you don't have repeated values here. So in other words, there's only one answer that's going to come out when I use -2, and that was going to be 2. I don't come up with this -5 down here. It doesn't work for that because that's out. So, and if you were to graph these, you would have a closed circle on one and an open circle on another, but there would still be the rule of function. The vertical line test would be met, all right? So that's why we call it piecewise functions, not just piecewise expressions, all right? So that's what we're looking at here today. Now, let's look at this f of 2. That means my x is equal to 2. Hey, which of these takes care of it? The x that is greater than or equal to 2. Exactly. You all are on it out there. You got me? So what's going to happen? We're going to use the function that tells me greater than or equal to 2. We're going to use the 2x minus 1. So we're going to say 2 times 2, and we'll subtract 1. We don't deal with x plus 4 because it's close, less than 2, but equals to 2 is down here. You see, it's taken care of somewhere. It's got to be somewhere in the function, okay? Every value we pick, no matter how small, how positive, or how negative, it's got to be somewhere, and that would even include 0, 0 is somewhere on this continuum, all right? So that's the idea. That's the idea of our piecewise functions. By the way, we're going to get what here? 4 minus 1, which is 3. And while we're at it, let's pick up 3. Put the function of 3 in there and see what we're going to have. Well, 3 is definitely greater than or equal to 2. So again, we're going to go with our second function here. It's going to be 2 times our 3 minus 1. And this time we would get 5. And we're going to do another session. We're not going to graph any of these today, but we're going to do a session, another specialized segment session on graphing these piecewise functions. So what you see, very similar here, but we're going to put it on graph paper another day, all right? And it's really cool to see how these things just have little gaps and breaks in them, all right? So a lot of fun there. And hopefully we'll get to some practical examples. You say, these things get used? They really do. They really do. Trust me on that. Trust me on that. Okay, let's look at one more piecewise function here. Actually, we may have 2 or 3 more to look at here. But here we go. This one we spread apart a little bit just because I like that, all right? And here we go. We got f of x equaling, and the thing is, we've got 2 options, an x minus 5 up here. And by the way, that's in case x is less than negative 2, all right? And here we go with a 2x plus 3 function, or expression as we're going to use. And it should work as long as we're greater than or equal to negative 2. Once again, there's no overlapping between our domain here. This is the domain for x minus 5. This is the domain for this one. So again, the whole function itself, the whole f of x, is still a function because you don't have any repeated values for x. In other words, x at negative 2 is going to give you only one possible answer because it's going to go right to there, okay? Now, let's take a look. And by the way, that is one of our questions here. So let's take a look at f of 1, our function of 1. Okay, asking myself, I've got the value 1. Is it less than negative 2? It is not. It is not. It's to the right of negative 2 on the number line, so it's greater than. So here we go. We got to go to this little guy. So we're going to use this function, our 2x plus 3. So here it is. And we're going to say 2 times 1 plus 3. So the value that we're going to assign 1 is based on this little guy, the 2x plus 3. And that's going to give us, looks like 5. That was easy. Except breaking up is not hard to do, all right? It's going to be very easy for us to work through these. What about f of negative 2? Where are we on the continuum? I jumped, didn't I? How about f of negative 3? Let's go with that. Which function will we use? Well, it's certainly less than negative 2, so that tells me go with this little guy. So we're going to use our negative 3 minus 5 there. All right, negative 3 minus 5, you got it. Negative 8, right? Negative 8. Everybody got that? That one's not hard, okay? Like I said, none of these are hard. Just like a negative 3 plus a negative 5, and you're on your way. Now, what about my last one over here, this f of negative 2? We've got negative 2's running all over the place, but only one place is it equal to negative 2, and that's in our second function here, our second expression, if you will. So here we go. 2 times negative 2, add 3 to that. Looks to me like we're going to get a negative 4. How about it? Plus 3, which is going to give us negative 1. So there's your final value. And again, like I said, these are like x, y things. So your ordered pair here would be 1 and 5, okay? Here would be negative 3, negative 8. Here it would be, looks like negative 2, negative 1, all right? So again, you could graph these like ordered pairs, x and y's. But f of x is sweet because it's just like a little hold there. It's like put my number in here, replace me with a little parenthesis, just like you see here. F of negative 2, just plop that thing right in there for x and see what happens. That's all it is. It's greatly substitution of your variables with a given number to put in there. Called domain if it inputs, range if it comes out as an output. So there you have it. Now, you say, Ernie, can it get any tougher? Well, maybe. Let's take a look at our next one here. You say, oh, 3 of them. Yeah, we got 3 of them here. Our f of x could be 2x plus 3 if x is less than 0. So that tells me if x is a negative number, I'm using 2x plus 3. A lot of times students don't realize that there's more than a hint to a hint than this. It's telling us that it is less than 0, so it's got to be a negative value, all right? Our answer is going to be 4. I don't care what was going on here. It's going to be 4 if you're somewhere between 0 and 3, and you can hit 0 or 3, all right? And then last but not least, we've got this negative 2x plus 2 if we get an x that is greater than 3. Now, I'm not going to guarantee everything's going to get used, but I hope it will. I think it will on this. I think it will, all right? So let's see what happens. First of all, let's take it at f of x, and I'm going to take just a little bit slower here on this one. You got -5, so we got 3 places to choose. And by the way, notice all 3 of our domains here, or these 3 pieces, if you will, are going to accommodate these values somewhere. There's one place it's going to fall. Got to be one place only. And this one looks like we're going to the f of x is equal to 2x plus 3. That's where I put numbers that are less than 0. So let's do it. We're going to have f of -5. I believe that's our value, isn't it? Yeah, right there it is. And that's going to give us 2 times -5. Add 3 to that. And I believe you're going to have -7. I'll do that little mental math there. How about -10 plus 3, which will give us -7, all right? Let's check out f of 0. Now, which function does f of 0 go with? Well, it doesn't do much at all, does it? It says basically we're going with the f of x. That equals 4. And it says any number between 0 and 3 inclusive. That means we can include 3 and 0 right in there. You're going to get 4. So 0 matches up with 4, all right, from that little stretch from 0 to 3. Doesn't budge. And last but not least, what have we got? It looks like an f of 4, which is greater than 3. So we're going to use the f of x equals -2x plus 2 right over there. And we're going to replace the x with 4. All right, so here we go. So we've got f of 4 equaling -2 times 4 plus 2. All right, working that one through looks pretty easy, right? Should be. -8 plus our 2, which will give us the -6. So there you have a feel for piecewise functions. I can make as many as I want. I can make as many as I want going down through here where different things, different outputs or outcomes happen based on what my input is, all right? So that's what's going on there with those. Now, I think we got time. Yeah, we got time to look at one more here for a little bit of practice. So let's take a look at this one. It's the one we just used here with a little bit of different boundaries, all right? And I want you to notice, once again, every number for a domain has a place to go, all right? In other words, we got numbers that are less than 0, that are negatives go here. Numbers that are between 0 and almost 3. Means if I got a 2.9999997 or something like that, it's still inside this little category, gives me 4, all right? Over here, I finally pick up 3 or greater than 3, I will use this function. So let's take a look at our 3 examples here, all right? We got the function of 5, f of 5, all right? Now, I'm going to use the one that goes along with greater than or equal to 3. Hey, you all getting onto this right? 5's bigger than 3, so we go to that function. So here we go. We're going to use the f of x equals -2x plus 2, all right? Put the 5 in for it. So f of 5 equals -2 times our 5. That's a negative. Sometimes my negatives don't quite come out pretty. And we got plus 2. We got plus 2 there, so let's multiply it out. That's a -2 times 5. We've had that one before, haven't we? Or we had a -5 a minute ago. This time we got a +5, so be careful with it. Sometimes I, trick you up a little. So how about -10? Add 2 to that. I see a -8. Slide right down. Let's go to f of 3. Which function are we going to use? Well, we're going to use the same one, right? Because it says greater than or equal to 3. So this time we're going to use f of 3 to go with our -2 times 3 plus 2. And let me just write right above there, that's the f of x function. We're going to use -2x plus 2. I really like to do that, keep it straight, all right? Keep it straight on it. And that's all right. Some of you are going like, well, why didn't you use something different? Well, because that's the description. It goes right there with that -2x plus 2. And let's do it. -6 plus 2, which equals -4. And last but not least, we got that f of 0. And that's going to use our f of x equals 4 function. So you know what? F of 0 pops right in there as 4. There we have them. That is a -4, by the way. There's a big negative. Want to include? And there you have our values there. So a little bit of practice there with piecewise functions. Now we're going to take them next week. We'll work with them some more. And we're going to do some graphs with them, all right? So you can really see what cool pictures they are. Now, like I said earlier in the show, we love when you like us on Facebook. Today's a great day to do it, all right? www.facebook.com/TNLearn. And of course, there's our address for you to send email or comments, Mathline@TNLearn.org. Check out the problem of the day. And hey, this show may even pop up there on YouTube also, www.youtube.com/and with TNLearn. We are out there to help you out, folks. That's what we're here for. We're trying to serve you and help you in your math skills. And I know a lot of you actually do tune in because you tell me about it. You tell me about it. So again, we'll be back again live this coming Monday, but we're glad you've tuned in today. It's Piecewise Functions. Breaking up is not so hard to do. Just remember that. And you know what? Be back with us because we don't want you to break us with us, but we want you to be with us next Monday. See you then.